Hello, we will solve a problem in this video. You take down this problem and pause the video and solve it, and later you verify it. Okay, so what is the question here? Derive an expression for IL and I1. So we have a voltage source 18 volt and a switch where t equal to 0, switch will be open, and we have one resistor here 90 and another resistor 60 and another resistor 120. They are in series, and we have one inductor 1 millihenry and one resistor 50, and 2 milli and 3 milli are in parallel, two more inductors, and current passing through this inductor is IL. Okay, so you may feel that so far we have considered only one inductor, but in this problem we can see there are three inductors, but they can be written as a single equivalent inductance. Hence it belongs to the RL circuit category only, single inductor category only. Okay, so this 2 and 3 are in parallel and together they are in series with 1. So I can write a single inductor. Okay, so what we will do now, first step, we will write a circuit when t is less than 0. T is less than 0, switch is, that time it is closed, switch is closed. So what happens? So that's why 18 volt I have written here, switch is closed, and a 90 ohm resistor is in parallel with 18 volt, that is we have written here, and another two resistors, this 120 and 60, they are in series and they are together in parallel with 18 volt because switch is closed now. So 120 and 60 are in series and they are in parallel with 18 volt. So that is what we have written here. Now this inductor I will replace it by, these three inductor I will replace by a single equivalent inductor. How it is? It will be 2 millihenry parallel with 3 millihenry, and that will be in series with 1 millihenry. So if you calculate 1 milli plus 2 milli parallel with 3 milli, you will get 2.2 millihenry. Okay, so I have written a single inductor with the value 2.2 millihenry. And now 50 ohm is in series with this inductor. So that's a 51 ohm is in series with this inductor. So that's why I have written 50 here. So totally, if you see the 90 ohm resistor, what we have one inductor in series with the resistor, and that is again in series with two parallelly connected inductors. So that I can replace like this. Okay, this is t is less than 0. Now t is greater than 0 we will take. So here switch is open now. We will go back to the original circuit. Switch is open now. So switch is open means this 18 volt will not come into picture. So then what we have, 180 ohm resistor in parallel with 90 ohm resistor. So that only we are writing here. 180 ohm resistor in parallel with 90 ohm resistor, and these two part is similar to previous one. That is three inductors we will write as a single equivalent inductor and 50 ohm resistor. So this is what at t greater than 0. Okay, so we have two circuit, t less than 0, t greater than 0. Now one thing we have to see, inductance resists abrupt current change. So for this circuit, t is less than 0, it was kept like that for a longer period of time. So that time inductor will act like a short, and current passing through the inductor we have to calculate. And t greater than 0, I have written the circuit diagram, but when t equal to 0 plus, that moment current through inductor will not change. So inductor can be replaced by a constant current source. At what time? At t equal to 0 plus time. Later you have to replace by inductor only. Okay. So step 1, we have to first calculate IL of 0 minus. So IL of 0 minus we have here. What is IL of 0 minus? This inductor will act like a short. So 18 volt battery is there across 90 ohm, 50 ohm and 180 ohm. So what is the current flowing through the 50 ohm? The same current flows through the inductor. So it will be 18 by 50. So you will get 0.36 ampere. So simply divide the voltage across resistor is, this is short. We know that inductance, if a constant DC means current DC voltage if you apply, it can be modeled as a short circuit. So it is something like 90 ohm is in parallel with 50 ohm is in parallel with 180 ohm. Okay. So that is the current flowing through the 50 ohm is 18 by 50. Now IL0 plus. IL0 plus we know it is same as IL0 minus, that is nothing but 0.36 ampere. Okay. That is the step 1. And we have to note here, since IL current will have the form of A into e power S1t, all the currents in the circuit will have the same form. So if you see, the voltage also will have the exponential decay form. So what is the question asked here? You have to find not only, let us see here, you have to find the Dirac expression for IL as well as I1. So you have to get an expression for I1 also. Since inductor is there, IL will have the form, we know that A into e power S1t, but I1 will also have the same form. Okay, but the A will be different. A will be different. That is, initial current value will be different. So every current will have the form of A into e power S1t in the above circuit. Okay. So for that, I1 of 0 minus, actually we don't need I1 of 0 minus. Why? To calculate IL of 0 plus, we need IL of 0 minus, because inductor resists abrupt change. But I1 is the current flowing through the resistor. So to calculate I1 of 0 plus, actually we do not need I1 of 0 minus. It is not dependent on the current at 0 minus. I1 0 plus can instantaneously change because it's a resistor. But still we will find out all the values. Okay. So I1 of 0 minus, so I1 of 0 minus, if you consider here, the current flowing through this resistor is 18 volt divided by 90. So 18 by 90, that is 0.2 ampere. Next one we have to find I1 of 0 plus. So this should be calculated independently, not looking at I1 of 0 minus. But I1 of 0 plus will depend on IL of 0 plus, that is there. So that time what are the currents flowing, it will be dependent on those currents, not I1 of 0 minus. So if you see the circuit here, again, how we can calculate, I know IL of 0 plus, I have to calculate I1 of 0 plus. So how we can calculate this one? So I can use current divider formula here. Which current is entering these two branches? We have two resistor branch, 180 and 90. And IL current is entering here, IL current. So, here, the second circuit you have to see, because this circuit, the pink color that belongs to t less than 0, you have to refer t greater than 0. So in that, you have two branch 90 and 180. So this I1, you can calculate I1 using current divider formula. For that, input current for this one is minus IL, I will take, because IL is in this direction, I1 is in the downward. So I have to take IL as minus. So minus IL, and current divider formula is what? Resistor of other branch, that is 180 divided by total resistance, 180 plus 90. Okay. So I1 will be minus IL into 180 divided by 180 plus 90. You just refer current divider formula, then you can write. Only doubt will be here why IL is negative, because IL direction is this side, but I1 is downward. So that's why it should be minus. Yes. So I1 of 0 plus is minus IL of 0 plus 180 divided by 180 plus 90, that is minus 0.24 ampere. Minus 0.24 ampere. Okay. Third step, we have to find time constant. For that we need R equivalent, L equivalent. So R equivalent, how to calculate R equivalent? See this circuit. R equivalent is the resistance, equivalent resistance seen by the inductor. So what is the resistance seen by this inductor? That is nothing but the equivalent resistance. What is the resistance seen by this inductor? You can see here, 90 and 80 are parallel and they are together in series with 50, that will appear across this inductor. So that's why R equivalent, just see R equivalent, R equivalent, it is 180 parallel 90, and that is in series with 50. This equivalent resistors appears across the inductance. And L equivalence we have already calculated, 2 milli in parallel with 3 milli plus 1 milli, that is 2.2 millihenry. Okay, I will show once again the circuit diagram. See that how 180 parallel 90 plus 150, that will appear across this inductor. Okay, that's R equivalent. Okay, next, tau equal to L equivalent by R equivalent, that you will get at 20 microsecond. You just make the calculation, you will get that. Okay. Step 4, we can directly write now the expression for IL of t and I1 of t. What is the expression for IL of t? IL of t is nothing but IL of 0 plus into e power minus t by tau. Standard equation. IL of 0 plus we have calculated already, that is 0.36 into e power minus t by tau, we have calculated 20 micro. So IL of tau we have two values, one is t less than 0, another one is t greater than 0, greater than or equal to 0. So t less than 0, we will have this current. So under the steady state we had this current 0.36 ampere. After the switch is open, this is the current 0.36 into e power minus 50 kt, because this is t by 1 by 20 micro, that will be 50 kilo. So you will get 50 kilo, 50 kt. Okay, so that is t greater than equal to 0. Now this one is very important, I1 of t. So not only inductor current, all current will have the form of A into e power s1t, but A will be different. A will be not here IL of 0 plus, it will be I1 of 0 plus, that we already calculated. It is minus 0.24, we have calculated that already. It is minus 0.24 into e power, but this constant R by L, this constant is same, this constant will not change. Okay. So this minus 50 kt will be same. But here I1t, observe, t less than 0 it was 0.2 ampere and direction was positive, and t greater than equal to 0 direction is negative and value is different. So current through the resistor can change instantaneously, but current through the inductor cannot change instantaneously. That's why you are getting different solution here. Okay, that's all.